And
We're ready.
will you behave?
I will do my best.
I'm gonna
try and go
give them
slow.
some time cues just in case.
Okay.
I've removed so many words.
And then we're gonna go 45, and then we'll do 15 of conversation.
I will stick to, I've
You
got
and I
my
will
timepiece
consult
here.
about that.
Well, let's get started, because man, I want my 45 minutes. Don't be yabbering.
You get
All
your
right,
45.
45 minutes.
Time to begin.
Yes. Good evening, everyone.
Because you've got the misbehaviors now.
What is?
We're in control now.
What do we do?
Let's have a party.
Hey, Jaya. You want to give the talk? Welcome back. We've had a great conversation, and I bet many of you have as well. And looking forward to more. And we'll have not too much time for conversation tonight. Adam's going to speak for 45 minutes, and then we'll have about 15 minutes. But we hope to maybe make some more space for conversation tomorrow, if we can sort that out. But in the meantime, allow me to briefly introduce Adam Frank. He received his PhD in physics from University of Washington. It's amazing who they give PhDs to these days, but no. And sorry. He held postdoctoral and visiting scientist positions at Leiden and University of Minnesota. And he was awarded a Hubble Fellowship, actually, in 1995, which I did not know. And he's now at the University of Rochester. It says you're an assistant professor.
I know, I don't know when they're going to promote me.
Yeah, right. I know that that's not true. Physics and astronomy, and so in any case, I know I'm bungling this, but I'm a little burned out right now. What I really know Adam as is both as he's a good friend, in case you can't tell, but also Adam is one of the really greatest science communicators I know. He's of course very well established as a researcher, and he's done a wide range of research. He's very interested in information theory. He's done a lot of work on alien civilizations which is not a joke, actually. That is a real thing. And you can check out his very accessible version of that in his new book called The Little Book of Aliens. But Adam is also one of the co-authors of The Blind Spot, which is a wonderful work which we've been hearing about, that does a great job of communicating some really difficult issues in clear and accessible language. So without further ado, because we're going to hear about The Blind Spot right now, I'll turn it over to Adam.
Thank you. So it is an amazing pleasure to be at Symposium. 2018 was the first time I was here, and I have to say this series has utterly reshaped my thinking. A lot of where I'm at now, including what came from the discussions I've had here. So I am very grateful to Upaya, to Roshi Joan, to everybody, staff. Is there something I'm not doing?
The mic keeps cutting out. Can I put it on that chair?
Sure. How's that? Is that better? Excellent. Okay, so what I'm going to tell you about today is a book called The Blind Spot, which I wrote with Marcelo Gleiser and Evan Thompson. You already have seen Evan, so I don't need to show his picture, but I also want to show, okay, where are we? Why is this not? There we go. Marcelo, that's Marcelo Gleiser. The three of us, it's a long story, I'm not going to go into it because I don't have time, but I consider us to be the band. I always think that when we had such great conversations, that if we'd met when we were 17, we would have had the same energy, like, arguing about whether The Who were better than Led Zeppelin. So it was just amazing. So the book is called The Blind Spot, Why Science Cannot Ignore Human Experience. And I'm going to take you through today, the sort of pieces of the argument. Because it's very much in line with sort of the critique of, when we're talking about AI and we're critiquing AI, there's also sort of an underlying idea about what consciousness is, how science views the world, how science views experience and consciousness, that is very much part of what we're critiquing overall in The Blind Spot. So this is what the table of contents looks like. So the book starts off with an introduction, a philosophical introduction, and then sort of the origins, the historical origins. And then what we do is we show how this thing we're going to call the blind spot has negatively affected physics, from the physics of time to quantum mechanics to cosmology, and then life and mind, life, cognition, and consciousness. And then in the last chapter, we tried to point forward to what going beyond the blind spot might look like. Today, what I'm going to do, I'm really going to focus on what is the blind spot. Because this book, we're not really pointing to what comes next. That is the work of the future science. Right now, what I think is really important is for us to very clearly articulate what this problem is and how it infects almost the entire scientific endeavor. Okay, so really what this is something, the blind spot is a constellation of ideas that really is associated with the Enlightenment. So in some sense, the Enlightenment really transformed how human beings thought about themselves. And there was good parts about this, a vision of a just society grounded in science and reason. And there were obviously bad parts of this that really come to fruition recently, but they were always there. The industrial scale exploitation of other human beings in the natural world, an inborn racism, sexism, etc. This view of life as a machine that was just, everything was just a resource to be mined. And this was also part of this, what I'll call the reductionist logics of production. This, intense effort, whether it was communism or capitalism, didn't matter, of just extracting resources from the world. And, you didn't realize, you didn't have to worry about any kind of feedback. And really, the Enlightenment was the Enlightenment because of science, right? It's science that gave the Enlightenment its power, because science was emerging as a power. So it was a power as this incredible method, this incredibly successful method for interrogating the natural world. It emerged as a power as an institution, right? As these, you're seeing all of these institutions, the Royal Academy of Sciences, all of these different institutions that were going to speak for science. And that the powerful, we're going to talk about this, the powerful adopted the institutions of science became wedded to the institutions of power. And then as an economic engine, huge amounts of wealth were being generated because of the application of science. And it's during this time, as science is rising as a power, that there's a metaphysics, a philosophy that is also going to speak for science. Its claim was that this metaphysics was what science said. And because it claimed to speak for science, and science was so powerful, this metaphysics became powerful, or was adopted by the powerful. And this is what we're calling the blind spot. And so what I want to do is now, for the next 10, 15 minutes, just go through that in more detail. So this metaphor of the blind spot is, at the heart of science lies something which makes science possible, but also which science can't see, or particularly this worldview that it got associated with science can't see. And in nature, the blind spot is where the optic nerve connects to the assembly of the eye, and you need the optic nerve to see, but because of the optic nerve, there's a blind spot, so you can't see where the optic nerve connects. But it's that which makes seeing possible, but it also is blind to itself. So what is it that is science is blind to, or this philosophy is blind to? It is direct experience, right? Now, this is a very hard thing to talk about. We have a hard time, pointing to it. What's great about contemplative practice, that's the whole point, is to have, have an experience of direct experience, or have experiences of direct experience. But it also goes there's other names for it. Lived experience. This is my favorite one. Presence. To just be presence, or the verb to be, right? What is the verb to be? Also within the context of the philosophy called phenomenology, it's the life world. But in any case, whatever name you want to use, right? It's so close to us. There's a great line in one of the koans, the Zen koans, about it's so very close that it's so very hard to see. And in general, in the Western line of philosophy, there just wasn't much inquiry into it. There's streams of it, but not much. And we can talk about why that is. But it just wasn't really a concern. Whereas in the classical philosophies of India and Asia, there was a greater focus on it. So you saw more of an emphasis about, well, what do we mean by experience? So that is what we're saying, this metaphysics, this view of science, which came to be sort of it is now the dominant narrative of what science is. If you go to the bookstore and you buy a basic science book, this is what you're going to get. This often, you can call it the triumphalist view of science, that science can explain everything. Science is the only way to explain anything. This is what we're going to be talking about. So the historical origins of this, in the book, as I wrote this part of the book, I titled the chapter, or the subtitled it, well, it made sense at the time, right? Because it did make sense at the time. Because so first of all, the origin of the blind spot, while science was something that was growing, across cultures and civilizations for, a few thousand years, it reached its modern form in Western Europe, beginning, with the Renaissance. And so there's this line of the Abrahamic religious and theological traditions, and then also the Greek philosophical traditions that inform the philosophical narratives of the blind spot. But really, it takes off with classical physics, right? Classical physics is Newton, really Galileo first, and then Newton. And it's this powerful, powerful mathematical way of describing motion. So I call it the empire of dynamical equations. It was this series of equations meant to describe things moving in the world. So the first one was Newton's equations. You don't have to worry about knowing the equations. I'll just point out that in this equation, this thing down here is time, right? So it's always about motion and change. And what Newton's equations were the most powerful way ever conceived of describing motion and change, from the motion of the moon to a cannonball. And of course, the cannonball part was one of the reasons why it became so powerful. You could predict really accurately when you wanted to drop a cannonball on your enemy's heads, how to do it. But then what happened was, so out of Newton's dynamical laws, or dynamical equations, there was this upward moving spiral of abstraction. And later on, a guy named Lagrange reformulated Newton's equations in a very abstract way, which made them even more powerful. And then 100 years later, 50 years later, a guy named Hamilton came up with an even more powerful and abstract way of describing this, such that by the time you get to 1900, this formalism is the most beautiful piece of mathematics you could imagine, completely ornate, completely abstracted, and yet unbelievably powerful. It can describe things like, what's going on in an engine in exquisite detail, a collection of 100,000 stars all interacting. And so what happens was, especially for physicists, we love these equations, and we think these equations are written in to the fabric of reality. And you'll still see that language. If you go to YouTube and you watch a YouTube video about whatever cosmology, you're going to hear that language. Fundamental reality, these equations that describe fundamental reality. So these dynamical equations are going to be an important part of the story. So that's where the blind spot emerged from. The idea was classical physics was the ideal of science. Everything else had to look like, you had to make it look as much like classical physics as possible. We're going to do the science of history, so we're going to have equations that describe how nations rise and fall. It was that kind of idea. So what emerges out of this is this constellation of ideas that we are classifying as the blind spot. And I want to run through them because they're so important one by one. And then what we'll do is we'll look at how they sort of ended up sort of poisoning the view that we have of nature. So the first one is reductionism, and this is that all truths reduced to truths about fundamental particles, or what we call basal entities, that there's some substructure to reality, that basically anything that happens is really due to the dynamics of these fundamental entities. Now, those happen to be physics entities, and those are particles and their forces. So what that meant was there is a hierarchy of truths. There's a hierarchies of science. And so this goes like this, and maybe you've heard this. Sociologists defer to psychologists. Psychologists defer to neurologists. Neurologists defer to biologists. Biologists defer to chemists. Chemists defer to physicists. Because we're number one. Turns out we're not, because our physicists have to defer to mathematicians, and mathematicians defer to God. So, one step removed, okay? No fundamental truths in anything else except your basal structures, right? So art, dance, music, poetry, spiritual endeavor, They all reduce down to just some electrical circuitry in your head, which ultimately reduces down to the behavior of quarks. Okay, so what are the basal structures? Just quickly, basal structures are like the fundamental particles from the standard model of particle physics, quarks and leptons. And then people tried to find, we've been trying for a while to find the next level down. So these were the ideas of supersymmetry or so, or looking for quantum nature of space-time. So that's what we mean in physics. Okay, on to the next one. Objective ontologies. So this is the idea that anything that science finds, especially these basal structures, they are real, obviously really agrees with that. That these are real in and of themselves, right? These things are what's truly, truly real. They are like the furniture in God's living room. That's the way we refer to them, right? And so because what science describes is the furniture in God's living room, that means that science provides us access to an objective reality, right? Objective anymore, oh, you and I do the experiment, so it's objective that way. No, no, no. Now science is like giving us a perfectly objective reality to do. So it's the God's eye perspective science provides us. So this idea of perspective is going to be very important, so I want to illustrate it. So
Didn't get that one because there was a big thing in front of it. Yeah, just a little bit. Thank you.
can we move that? Can I? Whoops. Oh, okay. Science objects are real in and of themselves, i.e. they are the furniture in God's universe. God's living room, sorry. Okay, so we want to perspective, it's so important. So there's no better place than video. So let's say you happen to be in Sweden in 1985 and the island where you live is invaded by giant killer robots. And you've got to run around and you got to disassemble these giant robots. What does it look like? Well, from a first person's perspective, it looks like this. You're running around, you're looking around. Okay, so this is a first person perspective, and this is what's called a first person shooter game. So if you're wondering what's going on here, that is John Dunn, and that's me, because John Dunn and I spent about 6 months of our life, almost every night, in here. This is a game called Generation Zero. And if you didn't know, John is incredible. John, he's really one of the best gamers I've ever met. I'm not kidding, that's really true. Okay, so that's first person perspective. Now third person perspective. Third person perspective is like Spider-Man. Great game. But so notice what's happening here is like the camera is floating behind Spider-Man's shoulder. And as Spider-Man runs around, the camera's always just, I'm not looking out of Spider-Man's eyes. I'm looking from some disembodied view behind it, right? So the God's eye view is that's what it is, right? But you're still looking, right? So I always show every idea, especially in physics, is that look at the title of this book, Science and Ultimate Reality, Reality. The idea, the hope, the dream imbued in this title of this book is that physics offers the perfect the view from, the God's eye perspective of the universe. There's nobody there, but it's still, you're seeing, right? It's offering the perfect perspective on the universe. Okay, materialism and physicalism is the next one. That one's only the matter and fields described in physics, that's the only real thing. There's nothing else that's real other than what physics describes. And so what that means is that in principle, if I made a list of all the stuff that occurs in physics, that's it. That is everything you have exhausted reality with no residue. That's a very cool term in philosophy I just recently learned. There's no residue, right? So that's materialism and physicalism. Another one is the reification of mathematical laws. So this is the idea that mathematical physics kind of constitutes the skeleton, the invisible skeleton on which the flesh of the world is hung, right? And so this is an idea that goes back to that math is in some sense a higher or ideal reality than the version that we see. And this is, if you're familiar with philosophy, it's what's called Plato's doctrine of ideal forms. That the equation for a circle, that's pure, that is truly real, and all the circles you see in the world are just crappy instantiated versions. They're imperfect versions. But that math exists kind of in its own ideal realm, and what we're seeing here projected in the world is our experience is a corrupted version of it. Physicists love this. I am a lapsed Platonist, because when I was a kid, learning about physics and learning about mathematical physics, I totally bought into this because the physics is so beautiful, and the math is so beautiful. If you've ever, if you've inclined that way, it is as beautiful as any, jazz quartet or any painting or any dance you've ever seen. So this is very much this reification. Reification means to make a thing, make something a thing, to make the math not just, scribbles on a page. It's actually a thing in the world. Okay, the last one here is going to be that experience is an epiphenomena. Epiphenomena is a cool word. It just means something that's kind of like secondary to the real phenomena. So what this means is that experience, everything that, what we're all sharing right now, is nothing but. There's a lot of that that's a lot also in reductionism. You are nothing but. The idea in reductionism. You are nothing but neural computations in your brain. Your experiences, everything you are is just you are, as I like to say, a meat computer. And so this is this great idea of the brain in the vat, right? So this is a age-old philosophical idea. Very much present in popular culture, the Matrix. Has anybody seen the Matrix, right? That's really the basic idea. That basically I can just take your brain, take it out of your head, if you operate intelligently enough, you will never know the difference, right? I can project, as long as I have the currents right, you're running around in the world. So what that means is an experience is an epiphenomena of these computations. Do I? Okay.
Two mics combined.
Too loud. Okay, so, all right, so that's kind of an overview of of what we mean by the blind spot, the constellations of ideas. They're not there all the time in everybody's, it's not like there's, a list, exhaustive list you can find that somebody who considers themselves engaged in this philosophy say, oh yeah, I'm a blind spot philosopher. It's what we, when we looked at the ways that these ideas instantiate themselves across disciplines, everything from physics to studies of consciousness, these were the ideas we saw. And they often are together. Like you'll almost always find, almost all of them in the same place in people's ideas. Okay, so what's the problem with this? Like, well, why not? Blind spot, it's great. Turns out, especially now, like I said, it made sense at the time. It made sense from the 1600s to the late 1900s because this paradigm was working really well. But starting in the 1900s, beginning of 1900, it starts leading us into problems. And particularly where we are now, the blind spot really shows up as a crisis of meaning for society. Because on the one hand, this view sort of says we're insignificant, right? Here's the universe, here's a bunch of galaxies. Every picture, every dot in there is a galaxy, and every galaxy has 100 billion stars. So we're just one star in one galaxy, and so we're completely insignificant in the universe. But on the other hand, what we've been finding is that actually we are significant. Like on the one hand, you can't look at the universe from the outside, right? The universe is everything. So how do you recognize that we're where we're looking at the universe from and still have the cosmology? Quantum mechanics, as we're going to look at, quantum mechanics has really screamed at us that we play a role. Every measurement we make, we're actually playing a central role in. And then in cognitive science, Evan talked a little bit about this today. So there's a meaning, we're kind of stuck between two meanings right now, and I want to illustrate a little bit more how this crisis of meaning has manifested itself, at least in my fields of astrophysics and physics. So within cosmology and fundamental physics, the blind spot has led to this idea of a crisis in physics. We started developing ever more abstract theories of the universe. We started extrapolating the physics we knew from our accelerators to ever larger or further back in time or to grander ideas in search of a theory of everything. A theory that could account for, like I said, that would basically, if I could write down the one equation and everything in the universe would pop out of it if I just, did enough sub-calculations from that. It turns out that has not worked out. It has not worked out in a spectacularly not fashion. So that's why, here, this is from Scientific American, A Crisis in Physics. This is something for the New York Times that Marcello and I wrote, A Crisis at the Edge of Physics. And part of the problem was that these theories, as they're pushing forward to, encompass, everything, they ended up having to embrace more and more fictional quantity. So string theory, I'm sure many of you have heard of string theory. String theory was like, well, we can get a theory of everything if there are 7 extra dimensions of space. Like we have 3 right here in this room, but string theory is like, no, there's 7 hidden dimensions, right? And then you watch the TV shows about it and like, oh, physics, it's so amazing. We've discovered these 7 extra dimensions, but we never discovered them. It didn't work out. They never showed up. There's no empirical evidence for them. And in general, string theory, there's still some people who are really enthusiastic about string theory, but nobody else is. Nobody else in physics is, right? Other than those, because for a while everybody was like, oh my God, this is going to work, and it didn't work. Likewise, there's aspects of cosmology, something called inflation, which itself, has some really great quantities. But there's problems with it in that if the general version of it ends up producing not one universe, the one we're in that we want to explain, but an infinite number of unobservable universes, right? And to me, that's kind of a problem, right? If your theory only works because you need an infinite number of giant pink elephants, that's like, I don't know. Maybe one pink elephant, sure, but not an infinite number of them. So these fictions have multiplied to the point where it's really sort of feeling like we're losing our way, that we're so disconnected from experience, including the experience that happens in experiments, because none of these things have any experimental validation. And then we get to quantum mechanics. And so, I'm only going to I can't spend very much time on this. But, quantum mechanics, we could spend forever on it. But quantum mechanics began about 100 years ago, a little bit more. And we know explicitly how to use quantum mechanics. Like all of this technology is quantum mechanics. But for 100 years, we don't know what it means. So we have a calculus for it. But what it means in terms of the nature of reality, we don't know. That's why there's all these interpretations of quantum mechanics. So why is this? It's because, remember I talked about those dynamical equations, how much we love our dynamical equations? Well, it turns out quantum mechanics has a dynamical equation. It's called, oh, by the way, yeah, so here, it's now time for me to show the cute cat photo. Because why? Schrodinger's cat, right? We got to show Schrodinger's cat. So, okay, just to go back, what we found with quantum mechanics is that dynamical equation that we love, that we think is built into the structure of reality. In quantum mechanics, something really weird happens. So, okay, here's the cute cat. Yay. There's the equation. It's called Schrodinger's equation, right? And so what's weird about what's weird about this dynamical equation is it predicts, or the way the machinery tells us that if I can have situations where I can set the equation's going to set things up for me where I can have 2 mutually exclusive events happening at the same time. So the cat, like this, we don't need to go through it, but you can have a situation where the equations could predict, sort of, a dead cat and a live cat at the same time until you look at it, right? And then when you look at it, those possibilities collapse into either dead or alive. Right? Now, the problem with this is, remember I said, we love our equations. Those equations are sacred. They are, written into the fabric of reality. But now, with quantum mechanics, it's like that equation only works until you make a measurement. The equation gets a pink slip as soon as you look at the system. And this does enormous violence to that blind spot philosophy, right? Or that blind spot metaphysics. Because those equations were supposed to be, we're part of the equations. And here it is, every time I make a measurement, I have to turn off the dynamical equation and use a different law, what's called the Born rule. And so there are, there's been what I call the quantum interpretation wars for 100 years. And there's 2 different versions of the interpretations. There's a list of interpretations. Some are what we call ontological. They want to preserve that kind of blind spot, perfect view, and the third person view, right? That view of the, Spider-Man looking over Spider-Man's shoulder. And then there's what's called the epistemological views, which are the first person, which says, you know what? You're looking at these equations all wrong. This equation is never about the universe by itself. It's about us and the universe. It's about our knowledge of the universe. So here's a long list with the O means ontological, the E means epistemological, of interpretations. I won't go through them. I'll tell you that I love cubism, quantum Bayesianism. That's a subject for another time. But the point is, there's always a price to be paid. And what I mean by that is that blind spot view of that list I made of philosophical perspectives. Some of them you got to get rid of. You're just simply not, no matter what interpretation you take, you're never getting that world back. Okay. So this is what we mean by what I mean by that, how the blind spot is leading us to paradoxes and problems even within the field. And then we get to cognitive science and what he said, right? So Evan has already mapped out all the problems that third-person view produces when trying to think about cognition and intelligence. I'm going to skip over this for right now. So I just want to talk about the philosophy of the blind spot. One of the things we do in the book is try and set, there were already people as far back as 1900 recognizing the philosophical problem with the blind spot, and they tried to, and there are heroes in the book. So I want to talk a little bit about them. The first one is Alfred Whitehead, who is arguably the greatest mathematician of the 20th century. And Whitehead was an amazing guy, and he was also a deeply thoughtful philosopher. And what he identified, his critique of what we would now call the blind spot, is that what this view of the world does is it bifurcates nature. It splits nature off into, what we would now call sort of prime quantities, which are like the physics stuff, the atoms and the wavelengths, et cetera. And then the subjective things, the red of the sunset. And that you split the world into two systems. There's the system of science and what science describes, and then this sort of epiphenomenal side of what we experience. And so, but he was like, no, you should not do that. That's a huge problem. And as he said, the red of the sunset is just as much a part of nature as the molecules and light waves by which science explains it. He was like, there's no hierarchy. You can't put one above the other. And also what he had is this great idea of the fallacy of misplaced concreteness. And his idea was what he calls the accidental error, you can see I'm from Jersey, the error of mistaking the abstract for the concrete, right? The concrete is given. The concrete is experience. The concrete is not actually concrete, right? But it is, it's what's actually given to you via experience. It's irreducible. You can't find atoms of experience. But where the abstract are these ideas, these, the conceptual entities in physics. All right, our next hero is going to be Edmund Hersel, who is actually also a mathematician. This is interesting that both these guys were mathematicians. But he developed this idea of, he was the guy who founded phenomenology, which many people in this room are, fans of. And he had this idea of the surreptitious substitution, where the universe of mathematical physics is promoted to the status of objective reality. This is what we were talking about, the reification of math, right? That math, or mathematical physics, that's what's really real. And the perceptual world is demoted to the status of a mere subjective appearance, right? So this is this substitution. You're substituting these abstractions for reality. And he was like, the problem with this is you're taking for true being what is really just a method. The use of these mathematical physics, this is a method for describing experiments. They're incredibly powerful, and that needs an account, but that's not what's real. What's real is what is given. So what this leads to is he calls it the amnesia of experience. You forget that at the base of everything we do is experience. And the third part of this philosophically is what I like to call the ontological mania. This desire, that supposedly science is supposed to give us, the God's eye view, right? So this is actually, Thomas Nagel wrote a great book about this, The View from Nowhere. That, third person view is a view from nowhere. It is a view, it's supposed to go upstairs. It's a space without location. It is a time without duration. I could go on about this. We have put a lot of work into this part of the, about thinking about time, because right, we have a whole thing about relativity and that description of time. But all of physics, the time of physics, there's never any duration. There's never experienced time in the time of relativity. It's clock time, right? But clocks don't read themselves, right? So what this is the idea here is that this objective frame that physics is so fond of, or science is so fond of, is fundamentally unexperienced and unexperientiable, right? Nobody's ever had it. Nobody ever will. So therefore, there's Spider-Man again. Sorry, Spider-Man. This is a great guy. Really, this is a great game. No, there's no third-person view, right? That's really one of the fundamental things to come away from the blind spot, that this third-person view is a fiction. It is a useful fiction, right? You can do amazing things with it, but fundamentally, there's no such thing. And if you want to do science correctly, you have to start with the understanding that everything about the world actually comes from a first-person view, okay? So the important point here is to sort of see how this happened, because what we recognize and what we talk about is like, look, the whole process of science was designed to push experience away. That's how science became powerful. It was a formal way of getting experience out of the picture. So we're going to use here, I wanted to give you the parable of temperature to sort of see really cleanly and clearly how this, what Hersel or Hersel in particular identified, why it happened, how it happened, and why it was useful. And now we have to recognize, okay, it was useful, but we've reached the limits of its usefulness in some particular questions, like consciousness, like the nature of time, etc. So let's think about temperature, right? So every day, right, you get your daily weather report in Fahrenheit or centigrade, right? Here it is. I just made a clip from today, right? You look at that, and based on that, you're like, oh, that looks like the high is going to be, 74 degrees today. And you translate that into how warm or cold you think you're going to be, right? So you decide what kind of clothes you're going to put on, because you don't want to feel too warm and you don't want to feel too cold. So we have an expectation based on degrees Fahrenheit, what we're told about degrees Fahrenheit, about what we're going to feel with hot and cold. But how did that happen? How did we get there? The important point here is that distilling the idea of degrees Fahrenheit from the bodily sensations of hot and cold was actually a multi-century scientific effort, right? There were no degrees Fahrenheit. The universe doesn't have degrees Fahrenheit, right? We developed that out of this process that we developed of doing scientific investigation. So let's look a little bit more. So the theory of thermodynamics, which is incredibly powerful theory, it emerged out of the bodily sensations of hot and cold, which we learned how to scientize. And so how did it happen? Well, first of all, we developed this thing called the scientific workshop. This is an idea from philosopher Robert Crease. And the scientific workshop is this: we come together in these specific locations where we sort of isolate all the other events. We put it in a table, we put whatever we're experimenting with on a table, and then we evacuate the air so we can just probe, how the temperature changes inside this vacuum chamber. So you have to have this workshop, which is a community-driven thing. No one person builds the workshop. It is lots of scientists working together across space and time, building laboratories, establishing frameworks for how they behave. So there's like the scientific workshop. Then what happens is we find out of feelings of hot and cold, we find what Michel Bitbol, philosopher, calls the structural invariance, right? Okay, this water's cold. When I put my hand on it, it feels cold. That one feels hot. Maybe you feel something different. But now what I'm going to do is I'm going to take a glass beaker with some fluid in it. I'm going to put it in the one that I said was cold, and I'm going to see, where it rises to. And I'm going to do the same thing in the one that was hot. I'm going to record those, and then, that's now going to be my substitute for your bodily feeling and my bodily feeling of hot and cold. Okay, so it's something that we can talk about. That's related to the bodily feeling of hot and cold, but I can now get numbers out of, right? I can mathematize it. And then I start this ascending spiral of abstraction, right? So first I figure out how to have thermometry, how to do thermometry correctly. And then once I've established, degrees Fahrenheit, what that means, now I can start thinking about thermodynamics, about how if I, burn this kind of fluid, how much heat do I get out? I can have a theory of heat, etc. So it's this process, this upward ascending spiral, that I go from hot and cold to like the idea that like, the universe has degrees Fahrenheit in it. Right? That we start to think that degrees Fahrenheit, that's what's real. Your feelings of hot and cold, those are just a subjective epiphenomena. It's degrees Fahrenheit that are real, right? When in degrees, we've forgotten that it came from experience. It wouldn't mean anything without experience. Okay, so experience is the precondition for the entire scientific process. It is not reducible. There are no atoms of experience. And this is the most important thing, especially when we think about theories of consciousness. You can't take these abstractions that were deliberately squeezed experience out of them, and then think you're going to be able to get experience back from them. That you're going to be able to take these thin, powerful, but thin abstractions and somehow get the thing that you purposely pulled out back from them. So that's why, all these ideas of even a theory of consciousness just misses, some fundamental point about where the tools they're using came from and how they purposely lost experience. So, and this comes from, even Stephen Hawking knew this, right? He said, what breathes fire into the equations, right? The idea that there is still this animate. I love what Evan said, what was it? The feeling of aliveness, right? Or feelings of being, what was it? Was feelings of? Being alive feeling, right? Bath, that's my new thing, bath, right? Where's the bath come from, right? The equations themselves are nothing. It's the bath which is really where, the verb to be emerges. Okay, so I have 5 minutes left, so I'm going to quickly go through this. I just want to make a conjecture. In the book, we have what I call I wrote this part, the conjecture on political economy, where I just wanted to say that, when we think about all the crises we're facing, including AI, but climate change is one of them, that, because science was so powerful, any set of ideas, any worldview that claimed to speak for science was going to be adopted by the powerful. And so the claim is that the political economies that have been running the world since 1600, 1700, 1800, be they capitalist or socialist, it doesn't matter. They are infused with the blind spot, right? And there's, in the book we try to give a bunch of different, thinking even about economic theory about the way this happened. But basically, we live in a blind spot world. This is not just a problem for science. Because science is so powerful, this is the way we are all taught to view the world, including the way we're taught, this is just the way economics happens. And if you don't think so, you must be crazy, right? So, and again, that's what I mean. It's not capitalism, socialism, doesn't matter. Extractive industrial economies, that's the blind spot. Okay, last few minutes. Beyond the blind spot. I don't know. Basically, that's not, we're going to be writing a next book, and we're going to be looking for that. But I just want to make a couple of points about what might a science beyond the blind spot look like. Can there be a blind spot science? Well, there could be if you learn how to center the concrete, meaning experience, that you're sensitive to that surreptitious substitution. Science is power. We're not anti-science, we're scientists. We love science. It's just that you have to figure out a new way of doing science that doesn't make these mistakes. You want no bifurcation of nature. You want to begin with what is given, i.e. experience, and you need to account for the power of those abstractions. The math is powerful. Why is the math so powerful? I don't know. There needs to be an account of that. But the math does not substitute for experience. And we already kind of are beginning to see sort of elements of what this new kind of science might look like. So Earth system science, which is the science, how we understand climate change, is fundamentally based on a bunch of new kinds of sciences called things like network theory, right? You can actually see the networks. All these lights are literally networks of roads. Understanding that network theory is all about the relationship between things. It doesn't even matter what the things are. It's the relationships, right, that matter. So in some sense, it's not ontological, it's more relational. Very powerful theory. What's called complex adaptive network theory, which is another version, or just complex systems. That's a good way of thinking about it. Complex systems. We're developing, and the people at this conference, going back, have been part of this. When I think about what Francisco was doing in 1980, leading the charge for what is now finally, especially because interestingly enough, because of computers, is now a major force in science. And complex systems is an entirely different way of viewing the world. Information theory also, I won't go into this, but that's also, because what is information? Information, is it physical, is it not physical? There's different ways of sort of looking at it. So just to sort of sum up here, especially for my fields of physics, the blind spot view, the question is how do you take physics, all those basal structures, and have, consciousness or experience emerge out of it? The post-blind spot view goes the other way around. How do you embed physics in experience, knowing that I start off as with my experiences of hot and cold and motion, and how do I understand how physics and its power emerges out of that? So, when I talk to people about this, everybody wants to be well, how does consciousness emerge out of materialism or physicalism? And I'm like, that's the wrong question, because even to make that distinction between the physical and the not physical is already way downstream of experience, of the given, right? Before you divide the world into subject and object, That's where you want to start, right? So the idea of physicalism is you've already made a conceptual split. So what we're going to require here is a new image of nature. This is what's really exciting. A radically new image of nature. We're given this idea of nature, it's out there. Nature's out there. There's this thing out there, that third person view, that's nature. And yeah, you got something going on in your head, but you know. But imagine a view of nature that somehow always started from experience, with the recognition that experience is not just your experience. What I never talked about was the second person view, right? You are only you because of me. And all the other communities of learners, you think in words, right? Where those words come from, because you're a part of a community of language users. And your community of language users is part of a community of other human beings, of the life around that supports those human beings. And that community of life is part of communities of ecosystems, which goes all the way up to the biosphere. The entire biosphere is implicated in your experience. And by that, actually, the entire universe is implicated in your experience. There's, when we talk about the mind, we think about the mind is up here, but as Gregory Bateson pointed out, no, the mind's, it's distributed, right? Okay. All right, so I'm not gonna go through this. This was from last time, blah, 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 blah. So, and this is what is really beautiful about this view to me, is that there is no bottom, right? There is actually a place. My first book was about science and spiritual experience. And the word I tried to use as a scientist, as an atheist scientist, was sacredness. That there's, sacredness is kind of universal, and that, sacredness is this understanding of that there's more, right? There's more. And so I think that what's good about this view is it connects to that. It can connect to that sense, because really there's no bottom. It's a recognition, if you start with this experience, there's a recognition that words always fail, right? That beyond the blind spot, going beyond, lies a recognition that ultimately all words fail. All descriptions, all theories, they fail, because they're only designed to do something. Experience overflows them. So in the end, what you get, right, there's not just the scientific theories, but there is also the prajna paramita, gone beyond, the great beyond. Right? So it connects to that way. So we'll end with the poet Muriel Rukeyser. The universe is made of stories, not atoms. So I thank you very much. "45 minutes.
Exactly. I'm very impressed.
Coffee.
Thanks for outing me.
Coffee at 7:45, baby.
Yeah, all right. Thanks a lot for outing me as a gamer.
But you're a great gamer.
Now why do you have two mics?
Because I'm so special.
I see. That's why
One
you're
wasn't
so
enough.
loud.
I don't know, because one wasn't working.
Okay. We have one handheld. And
Do I still need both of these, or can I?
maybe let's put them on the ground.
Sure.
Is there a lavalier? Can you guys share this one? Is that okay?
We can have it.
You might want to turn it on. Yeah. Which one of those doesn't work?
Well, they were intermittently back and forth. It was good we had both.
Well, we don't have something for him to share.
I'll just talk loud.
I'm on a lavalier.
Yeah.
I don't want to share just one. You want to get?
So many mics.
You want to get another handheld, or is one of these working?
Too many MCs, not enough.
Is this a guy moment?
So while we're here, I'll say that we're going to try to go for about 15 minutes. And then Roshi will, it's either that or bring out, what's it called? The keisaku? The stick, yeah. So wonderful talk, Adam. And let me just ask first if either of you have anything you'd like to say at this point. If you're still conscious. Are you conscious?
Well, I was really glad you ended up with the mantra of the Heart Sutra. That seemed appropriate. But also, I remember your last presentation, you emphasized the value of not knowing. And I would say you have not met that criteria.
Molly?
Yeah, thank you, Adam. Obviously, Thank you. I am obviously very sympathetic to your view. And I have a question, which is maybe going to be a weird question coming out of sort of like, I feel like my field is worse than your field in the sense that, okay, like I think there are clearly blind spots that pervade all of science, but my intuition that I'm hoping maybe you can speak to is like, I did get on a plane to fly here and I am alive and that worked okay. But the science of human behavior is like clearly not telling us what we need to flourish. And so I'm just like, I'm surprised to see that you as a physicist think that this problem is even there. So I don't know, just that's my initial reaction.
Yeah, no, I understand that. And that's why, and again, I was pointing out how physics is held as the, the queen of science or whatever, because it offered the model supposedly that every other science was supposed to follow. And again, when I was giving that parable of temperature, that method works. For airplanes, it works really well. For pool tables, it works really well. But when you start pushing towards certain edges, and that's one of the things we have to recognize, I think, in a post-blind spot science, is when we've gotten to that edge. So things like the nature of time, where we thought, oh, I just need a theory of clocks and how clocks are read relative to each other. But in there was no sense of the duration of the experience of time. And now as we try and push towards the absolute frontiers, we realize like, oh, maybe there's a problem with our theory of time. So maybe the solution, is exploring post-blind spot theories of time. So physics was designed to work in a certain area where you could push experience away, and it does work great there, right? And that's why I said there has to be an account, a philosophical account, of why those theories are so beautifully powerful. But there's also the recognition that when you get to a horizon, to the horizon edge, then the current way we think about physics fails. And the important thing here, just now reminds me, quantum mechanics was screaming this to us since 1900. It was saying measurement, right? And for 100 years, we've been like, no. So, it was right there showing up for us that physics was trying to tell us you need to go beyond the blind spot.
You can keep it. I'm seeing both Kristen and Evan. Any comments, questions? Yes, Kristen?
Thanks, Adam. That was very cool. And I'm also very sympathetic to a lot of what you have to say. But I was wondering about One Science and whether they might have something right or have figured at least some steps towards the solution. I'm wondering what you think about this. And that's anthropology, because anthropologists recognize that they're part of what they're studying, and especially with these debates within anthropology about the approaches to studying anthropology from the inside or from the outside, this etic debate that was happening in anthropology at some point in the 20th century. Because I realized they were getting different answers when they were looking at a culture from outside as an objective observer, so-called, as opposed to joining the community and participating in the community and trying to study the community from the inside. So I'm just wondering if there's anything from anthropology that you think maybe can help us move past the blind spot in some other sciences, or am I wrong and maybe anthropology doesn't have anything to offer?
Well, I'll heed Roshi's advice here and say the power of my not knowing, because I just don't know really with anthropology. I don't know what those debates, only vaguely. But they do sort of trigger for me something in the debates about quantum mechanics, about this idea of one of the great debates now in quantum mechanics and the interpretations of what does it mean to have a subjective interpretation of the equations. Does everybody do the experiment and get the same answer? Is it possible for everybody to do, for two different groups to get different answers? So that inside-outside view, I think within physics we don't have. We're just beginning to even think if that's possible. We kind of don't want it, and I don't understand why. But I think it'd be, if what you're saying is true, it would be interesting that it was the science of people, that actually was the first science to recognize this. You get different answers if you do different ways. You need to take the measurer into account.
Yeah, I think it would just add, it would be interesting if it's the science of society, of groups of people, as opposed to psychology and the study of individuals, where we really made this progress.
I have a question, if I could, Evan, unless you want to say something now, Evan? So I've got a couple of questions, actually, and there probably won't be time for them. But let me ask one, and I'll ask maybe kind of two, and then you can see what you want to say about either, and maybe they'll come up again tomorrow. One of them is thinking about the workshop. I think you can also look, and I'm thinking now especially of sort of classical India. And I think there maybe is also a kind of phenomenological workshop. They wouldn't use that terminology. But that you can think of contemplative practices, at least certain kinds of contemplative practices, as creating a similar, what you might call, ecologically invalid, to use a term out of psychology, or sort of artificial setup for your experiments. But now you're not doing that in a physical workshop, but you're doing that basically within your own experience. But just like the scientific workshop, this workshop also requires lots of people to put it together. Yeah. It has a history, it develops over time and space, and it comes up with particular kinds of results that are not what you would get if you're just sort of observing experience walking around. So I'm wondering if that makes any sense to you, because that's going to be connected to something else.
For me, that makes total sense. I mean, I think exactly that, like the idea of shamatha and the stabilization of attention, which, right, you have to be part of a contemplative community, you have to work a long time on it, you have to spend hours a day doing it. It is just like, with thermometry, I had to find a room where I could control the room's temperature and the pressure in the room and then do something, they used to call it vexing nature, you poke nature.
Right, yes.
And here you're kind of doing the same thing with experience, but the idea, because you want to stabilize the phenomena, boiling, at what pressure does water boil at a given temperature? You need to stabilize everything so you can ask that question. So they do seem to be very similar.
Yeah, and I don't know if Evan's looking implacable, so I can't really tell what he's thinking.
It's the glass.
It's the glasses and the time.
The glass, right. Yes, I think it's an interesting idea. I think there are definitely similarities. There's an analogy. I think the way that I would be inclined to go with it would actually be to thinking about the contemplative workshop, if you will, as very much embedded in social. So this connects to anthropology, actually, very much embedded in social practices of ritual and of actually constructing experience according to certain norms, as much as disclosing some pre-existing experience. That's how I would be inclined to think of the contemplative setting. But one could then take that point and apply it to science as well, experimental science.
Right.
It involves constructing all sorts of artifactual things like, vacuum pumps and creating, strange hybrid objects, to use a sort of Bruno Latour way of looking at it. So I would almost want to look at it in that kind of constructionist way and not take it in a kind of, so let me put it this way, I wouldn't want to take it in a way where the idea was experience is what it is, independent of any practice or ritual setting. I would want to say the experience is as much constructed as disclosed, but then I would say that's true in science too.
Yeah, that's my point. In other words, that just like the workshop sets up, it's useful, it gives us useful knowledge, the scientific workshop, but it sets things up in a particular way that yields certain kinds of results. And I think that may be true of what I'm thinking of the contemplative workshop, which maybe has a stronger social element, but as you know, in the Indian philosophical traditions, the classical traditions, they also claim to be examining, and Buddhism is one of these, claim to be examining experience in this kind of workshop-ish way. And then one of the things that's interesting about that, I was thinking about as I've been reading the book, but also hearing Adam speak, is they came to some interesting similar claims about experience. And so what I'm thinking of, like, if we think just maybe, this is probably applied in Nyaya Vaisheshika and Sankhya, which don't worry about it, they're ancient Indian philosophical schools, but thinking just about Buddhism and like Dharmakirti in Buddhism, So Dharmakirti would endorse a kind of bifurcation, actually, and actually say that the bifurcation is built into experience, that we experience the world as separate from our minds, and and therefore his kind of, he has, as you know, a kind of representationalism, as a causal representationalism in his system, and the causes, depending on what level of analysis you use, the causes are external, or at least they're in some sense not directly my experience, right? They're in some sense outside of my experience, even if you go Yogacara. So, and then, yeah, sorry, he knows what I'm talking about. So does he, actually. And then the other thing that occurred to me, actually, is he has this claim that actually the surreptitious substitution, which is that we substitute our concepts for reality.
Right.
And we think the concepts are invariant and that they're what's real. And he says exactly the opposite is the case. In fact, the concepts are false, or they're distortions. The only thing that's real is experience. So the difference with Dharmakirti and the blind spot is that Dharmakirti is saying these things are built into human experience. So a kind of blind spot is not just the product of like scientists of Western science. It's actually a fundamental feature of distortions in human experience.
But, okay, so here's the interesting thing, I think, because I keep saying, like, look, as a mathematical physicist, there needs to be an account for why these work. These aren't games, right? I mean, when I showed you the Hamiltonian formalism of classical mechanics, it's incredibly, arcane, and it's so far from, I'm pushing a cart, right? And yet it works. It works in the most amazing, strange way.
Even though he was Irish. Sorry.
Yeah,
I'm Irish. I'm Irish.
You can make that joke.
Yeah, I can make that joke.
So, there needs to be an account of that. I'm not waving that away. Like, whatever system that we move on to, or a philosophical account, needs to understand, why does that work so well? And that maybe something like what Dharmakirti is saying is that's what it is. Like, maybe there's a part of this which is built in to, below it, there's the, from the Zen perspective, there's the absolute, which is this absolute form, the groundless ground, the formless form. But there's also the relative as well, which has all the, the separation.
But Dharmakirti is saying it's not built into the world, it's built into the way our minds work. That's right.
Yeah, so that's it. I mean, so this is a long, very interesting conversation we can have, because but I still, yeah, right. All right. Because I'm not sure about that. I still want an ontology. It may be, so like in Cubism.
It makes you feel
Makes you feel better. I need an ontology.
You feel safe in the
Graphic. But so the interesting thing about quantum Bayesianism is they want realism, but they're going to call it participatory realism. It's a realism. There wasn't one Big Bang. There's lots of Big Bangs. Every time, there's Big Bangs happening right now. It's always, experience in the world are this, which that's why the relative and the absolute,
The 5 ranks.
The five.
Sorry. We won't do that to you.
But so I think there's some really interesting ways that Buddhist philosophy, we didn't talk about Buddhist philosophy at all in this purposely because we didn't want to go down that road. But I think rather than that first generation of quantum mechanics and physics, the dancing woolly masters, which is just completely wrong, there's a new generation of where you're not saying like, oh look, quantum mechanics proves Buddhism to be true. Buddhism doesn't need quantum mechanics. But that the philosophies, the philosophical systems.
We also don't need neuroscience.
Yeah, that's a good point. But just that, like, there's now a new era where, like, Nagarjuna and Vasubandhu, they have things in their systems that may be useful for us in physics and other sciences for the philosophical background. We need a new metaphysics. The old one is exhausted. Ba-dum-bum.
On that note, Roshi, shall we?
Yes. Thank you for relieving us from suffering.
I had coffee, man. I'm still good for a half an hour.
You're the only one.
Yeah, right.
Adam and I will be out back, so don't mind us.
Playing video games.
Yeah, right. This is better than video games.
Okay, let's see. We'll do it this way. I'll let you do it.
It's on.
Okay. In light of all this, all of these words had only one really important point, and that is the ending of suffering. So the ending of suffering and how we can actually engage in that. You know, there is a terrible joke that George Dreyfus once
Oh,
said,
yes.
you know,
Yeah.
he said, you know, Christians love God and Buddhists love lists. So we've been listified, so to speak, today, not, but somewhat mystified as well.
Mystified.
I think it'd be good to sing the four vows.
Indeed.
Creations
Delusions are inexhaustible. I vow to transform them. Reality is boundless. I vow to free them. The awakened way is unsurpassable. I vow to embody it. Creations are numberless. I vow to free them. Delusions are inexhaustible. I vow to transform them. Reality is boundless. I vow to perceive it. The awakened way is unsurpassable. I vow to embody it. Creations are numberless. I vow to free them. Delusions are inexhaustible. I vow to transform them. Reality is boundless. I vow to perceive it. The awakened way is unsurpassable. I vow to embody it.
For as long as space remains, and as long as beings remain, may I too remain to end the sorrows of this world. Shanti Deva. We should do that again one day. So thank you, everyone. I think there are so many questions percolating up in our community, and our cadre of faculty filled with enthusiasm, and also the degree of receptivity that you were expressing had the co-arising of timelessness. And so we apologize that this was, in a way, mutual, but a little one way. So tomorrow, I hope we can, continue the conversation among and between you, but also come with good questions. I might be able to battle John down a few minutes at final presentation so we can explore a little more actively with each other. And I just thank you, Adam, that was extraordinary. I had a David Finkelstein moment. I was telling Adam I was very close with a physicist named David Finkelstein, who Evan knew quite well. He was part of the Lindisfarne community and so on and so forth. And he was, his main interest was in quantum topology. And we were in the civil rights movement together in the 60s. In any case, he used to talk quantum physics to me, and I always had the feeling I understood everything he said until he stopped talking. And then I was completely degoused, it was like everything was lost. But in a way, it was kind of what you were describing yesterday, Molly. the experience of transmission in terms of your connection with His Holiness. When you went back to actually listen to the exchange with the Dalai Lama that Molly had, he didn't say anything like what she had experienced at all. And so it's okay if you see things a little differently tonight. I can understand, and we support that. And exactly as you're suggesting, we are in this sort of moving in this exploration, which is actually last night and today has been a heavy critique of science. And who knows how, science is going to look like, even in, 5 years. So we're in a kind of phase shift and an inflection point. And this critique is really important for us to consider, because what Francisco suggested in his early work, in which we're returning to again, is the value of the first-person experience. So we will see you tomorrow, Noah, here or in the Zendo for Richie's meditation. John?
We could do, it might make more sense to meet here, because then we could just, we have the setup. I think it probably makes more sense.
So Richie, we will move the chairs aside. Richie will appear sort of digitalized magically through the benefit of physics. Great. So 7 a.m. for meditation practice that'll be guided by Richie. We'll have 8 o'clock breakfast. And then at 9 o'clock, is that right? We will gather for Richie's session, and that'll be followed by John and our collective session. So thank you so much, Adam. What an amazing evening. I didn't know if we could take in, another particle, but apparently we did, even though we might not remember it when we leave.
I took so many words out of it.
I said to Adam, reduce the number of words on your slides, please. I always like fancy stuff, that I don't understand. Okay, see you tomorrow.